All right, thanks everybody. My name is Ryan, and I am that Canadian guy. I'm coming to you from Ottawa, so it's great to be here in Poland. It's great to see Krakow. I've never been here before, and I've been having a really good time, so thanks for having me. I want to talk to you today a little bit about authentication and some of the ways that we've kind of traditionally done authentication and some of the more modern ways that we can do it. So this talk is really about JSON Web Tokens. That's the mechanism of authentication that I'll be talking to you about. Show of hands, has anybody heard of JSON Web Tokens, using them at all? Okay, so a fair number of people. So that's really good. You guys will probably be well versed in this then, and this will be sort of informative for those who haven't heard of them yet. So my name is Ryan. I work at a company called Auth0, and so we provide a service, basically a hosted service that takes care of all the tricky parts of authentication and identity for you. So we give you kind of a login widgets and a hosted database of users, and authentication can be added to any app in like 10 minutes or less. I'm working full stack, so Angular, React, and Node mainly. I'm a course author. I've got some stuff on Udemy and on Scotch.io. And kind of a newer badge is Google Developer Expert for Web Tech. So what I'd like to kind of suggest, I suppose, is that authentication as we've traditionally done it, so with sessions and cookies, is kind of old school. And you know, it might work okay, it might work well for what we'll call traditional web apps. So those apps that are doing round-trip requests to the server each time a new page is needed or new data is needed. These traditional methods of authentication, they work well for that. So if they work well, then what's the problem? Well, to get an idea of what the problem is, why don't we take a look a little bit closer at how traditional authentication works. So it looks a little bit something like this. You know, a user would come to your website, they would submit their credentials in a login box. So they give you their username or email and their password, and those credentials get posted to the server. And if everything checks out, they're looked up in a database. If everything checks out with the credentials, then a session gets created on the server. So this kind of in-memory session on the server. And a cookie with that session ID gets sent back to the browser, and that's stored in the user's browser. And then what happens is anytime the user makes a subsequent request to the server, that cookie automatically gets sent back to it. And that's the way that the user is verified when they make new requests to the server. So that's kind of, you know, how it looks in practice in a traditional sense. But it turns out there's some downsides to the way that this works when it comes to newer, when we're thinking about newer applications and newer architectures. So if you're building a web application today, chances are you're going to want to build something that's single page. You're going to want to build something with Angular or React. You want kind of a snappy single page app. And the way that single-page apps typically, or the best way they consume data, arguably, is with something like a REST API. So you want to have this API, this server, that is serving up data kind of as in JSON format to be consumed by your application. And really, with a REST API, it's not good practice to have state introduced to your API. So what I mean by that is that for any given request to the server, we should expect to always have the same result sent back. But if you're dealing with sessions on the server where the user is either authenticated or not authenticated, that's a stateful thing on your server. So that kind of breaks one of these tenets of REST that we should be following. Another downside is that cookies, so cookies being the mechanism that we get information from the browser back to the server about authentication for the user, they don't flow downstream. So we're seeing a lot of architectures now where people have kind of a distributed system, right? We've got microservices, we've got kind of different pieces of, your backend is kind of split into different pieces that are interconnected, but they're a bit distributed. And cookies don't flow well from one server to the other. So this introduces some issues when you need to authenticate your user beyond that single server. So it can't easily communicate between multiple servers. Another downside to this is that in this kind of setup, access control, so if we think about access control, things like checking if the user has the correct permissions to access the resource they're after, it doesn't, well, what it is that it requires database queries generally on the back end. So this introduces, you know, the need to make a query before you actually get the data that you're after to return to the user. You have to make a query first to see if the user is allowed to access those resources. And so this leads to some general kind of chattiness on the back end is what it does. So ultimately, I guess the message here is that this setup, this way that we kind of architect authentication in a traditional sense, it doesn't scale too well, and it can be a little bit memory intensive. And it's not really a big deal when you've got a new application, maybe it's kind of a small app, but it can become a big deal as your application starts to grow. As your application gets bigger, it starts to become a little bit, you have to think about these things. Memory intensiveness, more queries going on the back end, that sort of thing. It's stuff that you've got to think about. So what I'd like to propose is that there is a better way, and that better way is to do stateless authentication with JSON Web Tokens, otherwise known as JWTs. You'll sometimes hear people pronouncing them as JOT, is kind of one of the ways they go by. So why don't we take a look at what a JSON Web Token is. So it's an open standard. It's under RFC 7519. And basically, it's this method for transferring claims, what we'll call claims, securely between two parties. And so a claim is basically kind of an assertion, something that you want to say or assert about a user. And they're communicated via a JSON payload. So JSON Web Token, one of the characteristics of it is that it's compact and self-contained. It's kind of this complete package. And it is a great mechanism for doing stateless authentication. And we'll kind of see how that plays out. So let's take a look at the anatomy of a JSON Web Token. So over here on the left, I've got just kind of a simple token. You can see it's broken into three parts. We've got three different colors here. And you'll notice the three parts are separated by this dot here. So these three parts have very particular purposes, and we can go through those. The first part is the header. And the header, I'll back up one. The header is what contains information about the token. So it's going to contain information about the algorithm that was used to sign the token. It's going to basically just say that it's a JSON Web Token as well. The next is the payload. And this is kind of the meat of the token. This is where the information about your user, the claims about your user are held. So in this payload, we see we've got three claims. So these keys on this object here are claims. We've got sub for subject, name, and admin. And we should distinguish here between two different types of claims. So we've got a type of claim that's called a reserved claim. And there's a few of these. There's a few reserved claims like sub for subject. We've got EXP for expiry, IAT for issued app. And those are claims that are reserved by the JSON specification. They've got their own purpose. But we can actually use whatever we want in that payload. It can take any kind of arbitrary data that you like. You can put kind of whatever you want in there. So the last part here is the signature. And this is a very important part of the token, and it's what essentially ensures that it's secure. And basically how you get to the signature, so the signature being this last part here in blue, is you take the base 64 encoded header along with the base 64 encoded payload, and you run that through a hash along with a secret key. And this secret key is meant for only the server to know about. So the server knows about the secret key, but the client, the user's web browser, never knows about this secret key. And this is what we can use to verify that the token is in fact valid. And the reason that we can do that is because if the user was to go and change any of the information in their token, say they knew a few things about web development or JSON Web Tokens, and they tried to make a change to give themselves maybe a higher access level, it would throw the whole thing off, and the signature wouldn't be able to be verified. So why is it that they are useful, JSON Web Tokens? Why are they useful for authentication and authorization? Well, what we've got with them is they've got everything they need to basically securely authenticate and authorize users. So we've got information about the user in the payload. And we've also got a way to verify that the token's claims, so those things that we're saying about the user, we've got a way to verify that those claims are valid. They can have detailed information, such as scopes. So scopes, it's kind of the term that we use to talk about the user's access level. And the cool thing with scopes is you can get really, really fine-grained in the kind of permissions that you give to the user. So you can say that John Doe is able to access resource A, read-only, but he can write to resource B. So you can get very specific about the resources that your user is provisioned for. So again, ability to protect your resources with fine-grained access control. All right, so let's see this in practice. So to start out, it looks pretty similar off the bat to how traditional authentication looks, in the sense that you have your users come to your page, they submit their credentials, their username and password in some kind of login box. Those get posted to the server, but the difference now is that instead of a session being created, a token gets signed, a JSON Web Token gets signed for them. And that token is sent back to the user in the response, and then it's saved in the user's browser, usually in web storage, something like local storage. And then, anytime the user makes a request for secured resources, the token has to be sent along with that request. And the typical way to do this is to send it in an authorization header. So any subsequent HTTP requests that the user makes, the token goes along with that request as an authorization header. When the request is received then, at the back end, the token gets verified against that secret that, once again, only the server knows about. So there's that secret that is only known on the server, and it gets verified against that secret. And so the payload's checked to make sure that the token is valid. We can also check the payload to kind of figure out what the user should get access to, usually done with some kind of middleware. So if you're using Node or something, usually you would write a middleware to take care of that action. And if the request is valid, if their token is valid, if their payload says that they can access the resources that they should be, or that they're requesting, then that resource gets returned to them. But if not, a 401 gets returned to them. So, kind of, I guess the way to think about this now is things are being flipped a little bit, right? So in the traditional sense, we're basically asking the server every time a request goes to it, whether the user is valid, whether they have access to the resource they are requesting, that sort of thing. But in this sense, with JSON Web Tokens, we're now telling the server that the user has access to what they say they are. We're telling the server that the user is who they say they are. And the way that the server is able to verify that is with that secret key. So hopefully it's kind of apparent that this removes kind of a need for queries to happen every time a request comes in. So every time a request goes to the server, there's no need to query the database to see what the user's access level is. There's no need to make queries to verify kind of who the user is. Rather, we're telling the server, and the server can trust it because of that secret key. So why don't we take a look at this in action? So I've got just this GIF here. This is just a simple app. It seems to be running kind of slow, this GIF, but that's all right. So this is just a simple login box that comes from Auth0. And what we'll do here is just enter the credentials. And I apologize that this is moving pretty slow. It's much slower than when I recorded it. I'm not actually that slow when I type. Here comes the password. So just simple login like we'd find on any kind of typical web application. So we hit submit. The login gets posted. And what we get in the response is that JSON Web Token that I was talking about. And in this application, this is an Angular 2 application. And the way that I have it set up is to save that token in local storage. So what you can see here is that we've got a key of ID token. And then we've got this long, kind of opaque looking string here, which again is that JSON Web Token that has its parts encoded. And so now if we go to ping the server, what we've got is we can do a secured ping. So this is sending a request to a secured endpoint. And because we have that token, because we are attaching that token as an authorization header, which we'll see here in the network tab, because we are attaching that as an authorization header, the server picks it up and it's able to do the check on it against that secret key that it knows. and everything looks good. So that resource, this message in this case, this all good message, gets returned to the user because they had a valid token. So I really wish it wasn't so slow, but that's okay. All right, so the next thing we're going to take a look at in this, once we get to the right part, is that we're going to kind of prove that if the user tries to tamper with this, because remember, everything is saved here in the user's browser. They have access to it if they want to, right? If they know something about DevTools, they can see their token, and then they can take their token, they can copy it, and they can go to something like jwt.io, jwt.io. It's a site that's maintained by Auth0, and it's a debugging tool for JSON Web Tokens. So you can go over here, you can plug in your token, and what you'll get back is the decoded header payload, and then you'll have information about the secret. So we paste in that token, and so say the user is crafty and they want to maybe give themselves a little bit more time on this token. So tokens have an expiry, but they want to give themselves a bit more time, so they change their number. Excuse me. And then they take the token that they've just changed, and they try to use it. So in this case, what we'll see is that it's going to do something different than what we've got now. And the thing that's going to be different is that when the token gets to the server, because that signature piece, that last piece of it, because it's been thrown off, it's been invalidated by us changing that payload, what happens is we get a response, in this case, that says we've got an invalid signature. So I hope you can see sort of how this is kind of working out. It's we've got this client-side way of knowing these claims, these assertions about a user, and we tell the server that the user is good to go. So there are some common questions that come up when we're talking about JWTs. And so the first one here is, can't the token be altered if it's decodable? But like we just saw in that example, that as soon as you alter the token, as soon as you make a change to it, like we just did, it's going to throw the whole thing off. It's going to completely invalidate the token. The next one is, what kind of information can be stored in the payload? And basically, what you can store in the payload is really up to you. Like it's anything that you want, essentially. There are some things you should do to be reasonable. You don't want to store huge amounts of data in the payload because that's going to really increase the size of your token. And when your token size increases, that's more kind of, it takes more demand on the network requests that are going through. So you want to be reasonable with the size of your token, but you can put information about the user however you like in there. Next one is it insecure to have user data in the payload? And the answer to that is that if the user data is sensitive, like if it's kind of stuff that you don't want your user seeing for whatever reason, or it's stuff that if the token got mishandled somehow, that it would be kind of, it wouldn't be good if somebody saw that data, you want to keep it out because, again, the token is decodable. People can get access to the payload quite easily. So it's a good idea not to put sensitive information in there. And then the last one here is, what if somebody steals the token? And this is kind of the kicker. Basically, if somebody steals that token, they can access resources at your server just like your user would be able to. And that's kind of one of the keys of this, is that JSON Web Tokens should have a really tight expiry. So you should be doing things like maybe an hour. Some people go as far as making them only 5 minutes in lifetime. And so this is the way to help ensure that if somebody steals your token, that they aren't able to use it for very long. There are ways that you can keep your user logged in, doing things like token refreshing, so that's a whole kind of concept. There is, if you want to kind of secure that sensitive data that you might want to put into your payload, there are things like JSON Web Encryption, JWE. So there are options out there to make it kind of user-friendly and secure. All right, so that's all I've got for you. This is my Twitter handle, @RyanChenkie. I've got these slides up at this bit.ly link, and there's also a GitHub repo that shows how all of this kind of works out with a Node application that you could, it's like a Node.js API. You can kind of run it and see how all of this maps out. I will be back there answering questions. I'll be here for the rest of the day, and thanks again for having me.